Okay, in this video we will go over geometric series, and first I will go over this formula here for geometric series. And so the idea behind it. And we know with geometric sequence that the ratio of consecutive terms will be a constant. And so with geometric series, each term is multiplied by a constant. Let's say r. And so let's say, for example, your first term is a, your second term will be a times r, your third term will be a times r squared, because each term is being multiplied by a constant. And so what I would get is a plus ar squared plus ar cubed plus ar to the fourth plus dot 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 plus ar raised to n minus 1. Now, in order to derive this formula, what I could do is do the exact same equation but multiply both sides by r. So it's allowed. So I'm going to multiply s sub n by r and this stuff by r also. And so this a becomes ar becomes ar squared becomes ar cubed, and so on. And then the last term will be ar raised to n, and the term before it will be ar raised to n minus 1. And so now if I subtract both equations, if I subtract s sub n minus r s sub n, what I would get is the a term would remain, but this term would cancel, this term would cancel, this term would cancel, this term would cancel, and this term would cancel, and all that we would have left is a minus ar raised to n. And then the next step, I could factor out an s sub n and get s sub n parentheses 1 minus r is equal to a minus ar raised to n. Divide by 1 minus r, divide by 1 minus r, and then I would get this. Last step, I could factor out an a for the numerator and get a parentheses 1 minus r raised to n. And this right here is the equation for geometric series. An important note, you can divide by 0, and so r cannot equal 1. Now this part was kind of abstract. I'll do another example with concrete numbers. So let's say we have s sub 6. We have 6 numbers. 4, 8, 16, 32, 64, 128. And if you notice, 8 divided by 4 is 2, 16 divided by 8 is 2, 32 divided by 16 is 2, 64 divided by 32 is 2, and 128 divided by 64 is 2. So we have a geometric series. And so here I mentioned that the second term was a times r. The third term was a times r squared. And so instead of putting r, I could use 2. So what I'm going to do is multiply this side and this side by 2 and get 2 s sub 6 is equal to, this becomes 8, 16, 32, 64, 128, and 256. And then we subtract both equations. I'm simply following this because I want to kind of prove this, but maybe this was kind of abstract for you. So I will subtract both equations. So s sub 6 minus 2 times s sub 6 is equal to, so the 4 remains, but all of this is canceled except for 256. So 4 minus 256. Then I can factor out an s sub 6 and get parentheses 1 minus 2 is equal to 4 minus, so here I have 256. And here in this equation, it was a times r raised to n. And so we know that a is 4, so 4 minus 4 times 2, because r is 2, 2 raised to 6, because we have 6 terms, 1, 2, 3, 4, 5, 6. So next, divide by 1 minus 2, divide by 1 minus 2, and I get s sub 6 is equal to 4 minus 4 times 2 raised to 6 divided by 1 minus 2. I know 2 raised to 6 is 64, and 1 minus 2 is negative 1. So 1 minus 64 is negative 63, divided by negative 1, so we have 4 times 63, which is 252. Now let's do an actual problem. Determine the sum for the following. If you want to pause the video and attempt this problem, feel free. So first, we need to count how many terms do we have. 1, 2, 3, 4, 5, 6, 7. We have 7 terms. And we need to double check that the ratio of consecutive terms will be a constant, just to verify that we are dealing with a geometric series. So 9 divided by 3 is 3, 27 divided by 9 is 3, 81 divided by 27 is 3, and so on. So each of these terms is 3. So let's use that formula. So s sub 7 is equal to a, the first term. The first term is 3. 3 times parentheses 1 minus r. r is 3 raised to n. How many terms do we have? 7. Divided by 1 minus r. r is 3, so divided by 1 minus 3. And if you use a calculator, you would get 3,279. Likewise, if you want to also verify it, just use a calculator and do 3 plus 9 plus 27 plus 81, 253, 729 and 2,187, and you'll also get 3,279. And that's all we need to do for this type of problem.